If you want to hide something, there's no better place to hide it than in space. The expanse is everlasting, so much so, you yourself would probably not be able to find it. So, it isn't a surprise to know that the cosmos holds a fair share of secrets, and when I say fair share, I mean an eternity full of secrets. One such anomaly is dark matter. We're really not too sure what it is, or what it could be, but in their search for answers, scientists recently discovered a portal to the fifth dimension that is truly going to change the way we look at the universe. Where did they find this portal? How does it exist? And what's on the other side? Portal. Scientists are searching for a hypothetical particle that could act as a portal to a warped fifth dimension that mediates the cosmic realms of light and dark. You might think that sentence is a science fiction story, but it is actually the result of a recent study that tries to answer some of the most persistent questions in science. A particle called a fermion could explain the abundance of dark matter, an unidentified substance that makes up most of the universe's mass. This would also solve problems about subatomic particles called fermions. The study says that new physics can explain these fundamental mysteries by showing a model of the universe with a fifth dimension that particles can travel through. A fermion is a particle that follows the Fermi-Dirac statistics in particle physics. The fermion includes all quarks and leptons and all composite particles made of an odd number of them, such as all baryons and many atoms and nuclei. Fermions differ from bosons, which obey Bose-Einstein statistics. In the European Physical Journal C, a study was the first to coherently apply the theory to explain the long-standing dark matter problem in particle physics, even though the warped extra dimension or WED is not. Dark matter is the most important part of the universe's matter. It is the basis for our understanding of the physical cosmos. Dark matter plays a role in explaining how gravity operates because many characteristics would disintegrate or break apart without the X factor of dark matter. Even though dark matter doesn't interfere with the particles we can see and feel, it must have other unique characteristics. The scientists from Spain and Germany explain in their study that there are still some questions that are not answered within the standard model of physics. The study was authored by Javier Castellano and Matthias Neubert. The goal of the new research is to use a WED model to explain why dark matter exists. Fermionic dark matter and dark matter remnants might travel via portals into the fifth dimension, according to the researchers. The researchers are part of a long scientific tradition that questions whether the four dimensions that humans are capable of comprehending, 3D space and time, are really all the universe has to offer. Five-dimensional field equations have been produced to express the implications an extra dimension would have on the universe and reality itself. Higgs boson particle. These equations were investigated in relation to fermion masses, and it was discovered that there was a new scalar field associated with a speculative particle that was roughly similar to the Higgs field associated with the famous Higgs boson particle. The team explained, "We found that the new scalar field had an interesting, non-trivial behavior along the extra dimension. Since this new particle has very similar quantum properties as the Higgs boson, it was very natural to assume that the two particles should mix with each other, meaning that their quantum mechanical wave functions are intertwined." Studying this mixing was one of the original motivations of this work. As they looked into this idea, the physicists realized that the heavy particle could be a unique window into dark matter because it could connect dark matter to its more familiar counterpart, which is dark matter. The physicists explained, if this heavy particle exists, it would necessarily connect the visible matter that we know and that we have studied in detail with the constituents of the dark matter, assuming that dark matter is composed out of fundamental fermions, which live in the extra dimension. This is not a far-fetched idea, since we know that ordinary matter is made of fermions and that, if this extra dimension exists, they will very likely propagate into it. The models of the hypothetical particle did not conflict with the real evidence of dark matter abundance in the universe. The general agreement with confirmable evidence and the extensive mathematical work in the study suggest that the particle could be a possible new messenger to the dark sector. The team went on to say, therefore, confirming the existence of such a new scalar particle will open an exciting path towards the possible discovery of dark matter. This will give us in particular very useful information about the possible mass range of dark matter and its interactions with the particles we know nowadays. That scientists had a lead on this hypothetical particle, they just had to look for it. In 2012, the Large Hadron Collider, or LHC, in Switzerland found the Higgs boson, which won the Nobel Prize in Physics. The particle proposed in the new paper would be too heavy to be generated in any current facility, so the LHC wouldn't be equipped to search for it. In particle physics, the Higgs boson is an elementary particle produced by the quantum excitation of the Higgs field, one of the fields in particle physics theory. The Higgs boson is sometimes called the Higgs particle. The particle might be detected for a new generation of proposed colliders, such as the International Linear Collider, the Compact Linear Collider, or CLIC, and the Future Circular Collider, but due to its large mass, the prospects for detection are slim. The researchers continued, one of the most significant examples is the so-called hierarchy concern, the question of why the Higgs boson is much lighter than the characteristic scale of gravity. The standard model of physics cannot accommodate some other observed phenomena. One of the most striking examples is the existence of dark matter. However, the researchers believe that the particle could be detected more indirectly, such as through observation of gravitational waves, which are ripples in spacetime. The researchers further explained, another possibility, which we did not explore yet, is that this new particle could play an important role in the cosmological history of the universe, and might produce gravitational waves that can be searched for with future gravitational wave detectors. Fifth dimensional concept. The team is optimistic that their fifth dimensional concept will develop alongside advances in particle physics and cosmology. Future studies of dark matter could also help constrain the odds of the particle's existence. The particle could shed light on mysteries such as the flavor puzzle and the hierarchy problem. It could also open a new window into the early universe. The team said, one could study the potential role played by the new scalar particle in stabilizing the extra dimension. This could also eventually lead to an interesting cosmological history of the universe and might lead to the production of gravitational waves. This is a fascinating line of research, which we plan to follow in the months ahead. One could also try to find new ways of probing this particle at future hadron colliders. As you can see, there are really plenty of things one can think of. Could particles that travel between dimensions explain at least part of the dark matter that hasn't been found yet? We know that there is no dark matter candidate in the standard model of physics, so this fact already says that there must be new physics. A key mathematical concept makes fermion bulk masses that appear in the so-called fifth-dimensional warped space. A small, dark sector could be one reason why there is a lot of dark matter that hasn't been found using any standard measures for the standard model of physics. A distorted fifth-dimension portal may contain fermions that are acting as dark matter. To confirm this theory, we would need to detect this kind of dark matter. Dark matter theories continue to face this obstacle. But all that would be needed to find fermionic dark matter in a warped fifth dimension is a good gravitational wave detector, which is becoming more and more common around the world. Perhaps the solution to the mystery of dark matter is already within reach. So, what do you think? And when do you really think dark matter is? Let us know in the comments below, and as always, thanks for watching Space Nomad.